Hey guys, welcome to this video tutorial of Codechef June Cook-Off checkpoints problem. This was the fourth problem in the div 2 and the second problem in div 1, and it was a really great problem. It just involved one major step which you were able to take, then you will definitely get this problem accepted. So now without further delay, let's get to the solution. Here is the problem statement. You can read the problem, but if I explain you the problem in simple terms, it just says that there are n points in a 2D Cartesian coordinate systems. We are given these coordinates of all these n points and an fixed integer c. And in one operation, what we can do is that we can move any of these points to xi plus c, yi plus c, or xi minus c, yi minus c. So we will be observing that what would be this movement look like in a few moments. And now what we want to do in this question. Our chef wants to put some more checkpoints, so there could be one or more checkpoints which he need to put the points in the same coordinate system. That means in this coordinate system only he wants to put some more checkpoints and perform zero or more operations of this type, such that after performing all these operations, all the endpoints which were initially given to us are moved to one of the checkpoints, are located at one of the checkpoints. And the primary objective is to minimize the number of checkpoints, and amongst all operations, the operations with minimum number of checkpoints. He also want to choose the one which minimizes the number of operation he perform. So first aim which we have is to minimize the number of checkpoints, and the second aim which we have is to minimize the number of operations. So we have to take care of both of these, and then the question is that we have to just find this minimum number of checkpoint and minimum number of operations. Here is this input and sample test given. So now let's get to the solution. So in this question there were basically four observations. So the first one was, in which place can we move the points? So for the first observation, if we look, that suppose this was the Cartesian coordinate system and our point given was something like 1 comma 1, okay, and c was, let's say, 3. So if we see that this was x0 comma y, x comma y, then it is as it is given that in one operation we can just move to any of these two places, that is from x to x plus c and y to y plus c, or from x to x minus c and y to y minus c. So if we look carefully, that if we are standing here and suppose c is the given to us, then x plus c would be something, from this x we have to move c times this direction for x plus c, and corresponding to that for y plus c, from this point we have to move c points above. So basically if we see that x plus c, this would be something like here, x plus c comma y plus c. So this is the first thing that we can move using this, using the plus point. And now how will this x minus c and y minus c be there? So for x minus c, starting from this point we will be moving c points behind, and for y minus c, from starting from this we will be moving c points behind again. So basically if we see, this point would be x minus c comma y minus c, and if we are look at it, that the slope of the line joining these points would always be same. So now let me just draw this thing a bit more clearly. This was the line, suppose, and here is one point. Let's suppose here is x comma y, this is x minus c comma y minus c, and above this there is a point x plus c comma y plus c. So the distance between these two is same. You can just imagine for a moment, because the distance is looking to be low. So these are the 3 points and this is the line connecting them. So basically what this means, that if we consider this line just as an axis, then starting from this point, in one operation of this or this, we can either move it to a step of c ahead or to a step of c behind. And then if we do again this operation, suppose in the first operation we brought this here, and again if we do, then we can move this again c steps ahead, and again c steps ahead, and if we bring back at c steps, so in each operation we can just move at a step of c on this line. So this length would not be exactly c, it this this distance would be c, and this height would be c, to be precise. So we will now just make a quick note of it, that on every operation, so let's suppose this was the line, we can move it to a point. So from x comma y, so let's say x plus c comma y plus c, such that this distance is c and this height is c, if we draw it from here. So this is the x plus c and x minus c operation, and for that x comma y to suppose x minus c comma y minus c operation, we can move it to c points behind, such that this distance is c and this distance is c. Okay, so now I think this point is clear, that in how is the operations happening. So in each of the operation, what we are just doing is that we can move either c steps ahead or c steps behind, and in this one operation for positive we can move like this, and another we can move that this. So now if we see the second observation which you have to make is that how can points be clubbed together, because so let's suppose that this was given to us n points, and the one option which we can do is that we can make n checkpoints at each and every point initially itself. What that means is that suppose there are this and this point, we can make these points itself as the checkpoints, right? So at that, in that case, that answer would be n. So the answer would be n, but we have to minimize this number of checkpoints. So we have to think of a way that how can we just club these checkpoints. So basically, how can we club it? So directly, if we see in the given input, we cannot just say that it can be clubbed. We have to perform certain number of these operations to club these to one point. So let's suppose there is a point here and there is a point here which lie on this same line. That means the slope is same. So in one operation we can move this point back here and bring it this point here and make it this as a checkpoint. What will that do is that instead of making these two separate checkpoints, we can club them using one operation, and we can make a single checkpoint, and the prime aim is to minimize the number of checkpoints, and if the number of checkpoints are minimized, and then also we have to minimize the number of operations. So in this we are primarily minimizing the number of checkpoints from 2 to 1, and there is one operation being performed. Okay, so basically now we see that suppose this is a coordinate plane and there is these different lines, and there are various points on this line and this line and this line. So if we see clearly that these points can only be moved in this on this line, and these points can only be moved in these lines. So there is no way to club points on these different lines to each other. And how am I saying this as different line is that suppose this is x comma y, then let's take it with a concrete example to make it more clear. So suppose this point is 1 comma 1, this point is something like that means 1 comma 2, 1 units above it. So if we see that in any operation that this line would be different, that means this point will be moved on this line only in the step of c's, and this can be moved on this. So if there is some, let's say another point here 0 comma 0, so if we can combine these two in one point, then it would be really beneficial, as then we don't need to make two separate flags. So this was the second observation, which says that how can we club together the points. So all the points on one line can be clubbed. So now where should we gather all points? So basically the one thing is clear, that we can move these points on this line, and if it is possible to club them, then we should do it. But the thing is that where should we move, where should we club it? So for this, let's just again make a graph. So basically the thing is, suppose there are some points on this. So if we see that if moving this point on this axis, is just similar to that, moving these points x points ahead, because this line this slope is same. So in one operation, suppose we move this one operation, so we're just moving this point c steps ahead. And suppose if we move it back, then in one operation we are moving this point c points behind. So basically the operation just means that moving this point to c places ahead and behind. And correspondingly here also we can see. So at max on this line, if we just make a translation of this and consider this line itself as an x-axis, such that moving of one point c ahead can be considered like this. So we are just rotating this way to make it horizontal, and there are various points on it. So suppose if we move this point to here by moving it to C, then it basically means that we are moving this point C steps ahead horizontally. If we consider for simplicity, that means we are only considering the x coordinate, because we know that these are have lying on the same line. Then the y coordinate would automatically become same. If we change x by c amount, then y will automatically change by c amount. So this was the step that we can move this always to C steps. So what this conclude that for each point on this line, suppose this was at 0, x at 0, somewhere here, then we can move this point to somewhere to a multiple of C. So basically at the end, if we see that 0, 1, 2, 3, c minus 1. So if we categorize all these points such that the x coordinate of them remainder with c is something from this range. So suppose for this point and this point and this point, so x coordinate divided by modulo with c gives 0 remainder. That means in some multiple of c we can club these 3 points together. So now am I saying it? Let me just, so this is 1, this is 3, and suppose this is 9, and c is given as 3. Okay, so basically if we see that 1 c, no, it's not device, it's 1 modulo c 1 modulo c 1 modulo c is 1, 3 modulo c is 0, and 9 modulo c is 0. So if we see that for 1 it is coming z1, for 3 and 9 it is coming 0. So by moving this point first 3 steps ahead and then again 3 steps ahead, we can combine these 2 points into 1 point and make a one checkpoint here, one checkpoint here. So by this, if suppose we did not move this from this point, then this was 1, 3 and 9, so we need to make 3 checkpoints. But after moving this, we just now need to make 2 checkpoints. So here is the observation that we can group the points such that their remainder of their x coordinate is equal. Remainder of their x coordinate divided by c is equal. So here we have discussed the condition following which we can club the elements, and then how many steps are required and how to minimize these steps. This is the last observation which we need to take care. So suppose let's move on to the same example. So till now what we have discussed is that suppose this was some lines and there were some points lying on this line, some point on this, some points on this, then we can rotate each line to horizontally and consider each points individually, and by moving the x coordinate by c will automatically move their y by c, assume x because this is lying on this line. So if we move this here by c, then y will automatically move by c. Then if we can move this behind also and above also, so basically at this point we are having some points such that the x modulo c of this number could lie from 0, 1, 2 up to c minus 1. This is for sure because the remainder with c is somewhere between this. That means we can group these numbers. Suppose this point has remainder 0, this point has 3, this point has c minus 1. this has 2, this has 4, this has 0. So we can group these 2 points which has 0 remainder with C, because in one or certain number of operation we would be able to club them together as we did here, and all the others would be separate. But now if we see even more clearly that, then in this case there were only 2 points. So let's suppose there are 1 2 3 4 5 6 7. So there are 7 points with remainder 0. Let's suppose the data set was big, so there were 7 points with remainder 0. Then we also want to minimize the number of moves, because we are sure that we can club all these into one, because they're giving same remainder with C, that is 0. So after moving this by some multiple of C, it can become here, it can come here. So the most optimal way, if you observe, to minimize the number of operation would be bringing all of them to the middle point. What that mean is that bringing this point here, this here, so this is 7, so this is the middlemost point. So bringing this here, so bring this here, here, and here. So in this way, if we see that we are also minimizing the number of swaps by always combining them in the middlemost point. So I hope this is clear that we are always combining in the middle point. And now and now if we see that after combining them into the middle point, we are at the most optimal point, and after this we can just go for our solution. So now here if we see that we are having this point, so basically now let's formulate the steps which we would be following in our solution. So the steps would be something like this. First thing is that we need to find all these points on a single line individually. Okay, so we would be following a hash map sort of an approach, in which we would be forming a, say, the points on a single line which has same remainder with C. So point on same line with same remainder with C. So we would be forming a map of this, and the other thing would be the x coordinate of that point, because if we see that after rotating this line we just needed the x coordinate, and then if we can find this remainder with C and club the same one with same remainder. So basically we just need the points on this and point on same line with same remainder with C and their x coordinate, so that we can find the difference and then ultimately merge all of them into the middlemost point. So all of those which has the same remainder would be merged to the middlemost point. So now let's get to the code for clear understanding and a better clarity. So here is the code. The code is pretty simple and small. I will try to make it more better for you. So we are taking the input here. So basically this is the vector pair which I talked about. So it would be a pair which would be containing the points lying on the same line with same remainder with x. So how am I calculating the all the points with same line? So if we see, as we know in the 2D matrix, the sum of all these points, these points, these points, these points, and these points is same, right? The That means the indices of these all points. So similarly, if we do, that means the difference of these points are same. Sorry, I apologize for my mistake. The difference on point lying diagonally like this is the same. So here I am just calculating the difference of the given coordinate and the remainder which the x coordinate has with C, because we also want to combine those points into this x with same which has the same remainder with C. So these two pair which form a hash for us, in which the points which are lying on same line horizontally and have the same remainder with C would be clubbed. So this hash map would contain something like this. So let's say that this was the given thing. So there was this point A and B, C and D, so and C. So this hash map would contain A comma B together, C comma D together, and E together, condition that these two have the same reminder with C. And suppose this had, if this there was some say X here which does not have the same reminder with C, which A and B have. So A modulo C is equals to B modulo C is not equal to X modulo C. Then this X would be kept separate for us, because we would not be able to merge it with any existing ones. So here when we have to, after forming hash, I'm just counting the points and steps. So the second part of this map would contain this array of all the points which are clubbed together. That means their x coordinate which can be clubbed together. And I'm taking the second part, sorting the given array, and then finding the midpoint to merge, as we have discussed here. So we have to merge on the midpoint only. So I'm finding the midpoint, and then I'm just finding the sum of absolute difference between the mid position and the current. That means that, so this is suppose x1, x2, x3, so x2 minus x1 by c. This is the number of operation which I will be needing for bringing this point to the center. And suppose for this x4 point here, so it would be x4 minus x mid by c. So this would be number of operation which I would be requiring for bringing this point to the mid. And I am counting these steps, and at the end I am just printing these steps here. So I hope the solution was clear. If you had any doubt, please let me know in the comment section. I will make sure to help you. And this was the steps. We just needed to make this for observation, that point can be moved on the same line, and how can we club the point, and how to just analyze by rotating this line horizontally and clubbing with same remainder at the medium. So this was the whole story of the question, and the implementation was using a map, so that we are able to do it optimally. So thank you for watching, guys. I have more video content for CP related to this contest also. Do check it out, and do like and subscribe to the channel, as I will be posting more content regularly. Thank you, guys.